Yeah, the next question is about Bernoulli's equation. Water flows through a horizontal tube. Some people might have skipped this topic in the lecture, but this is a very easy concept and very easy question to do. Direct Bernoulli's equation application. Here, what the student can do mistakes. Okay, what kind of mistakes the student can do, that we'll discuss. Look at this. uh, 5 centimeters difference is there in the height. So guess where would the temperature be, pressure be more, at A or B? The pressure at A will be greater than the pressure at B. So some people might take the reverse, so there you might go wrong. And the rate of flow here is actually uh, should be calculated in centimeter cube per second. So some people may find it in meter cube per second. There the people may go wrong. Of course, the answer will not match because none of the options uh, are in decimals. Because if you calculate it in meter cube per second, the answer would be a lot different by a factor of 1000, not just 1000, 10 power 6. So, anyways, let us do the question now. The PA is given by P naught plus rho g h, where h I will consider it as 0.05, and PB, assuming it to be P naught. So here, this is what it is. And now applying Bernoulli's equation, you'll have P naught plus rho g into 0.05. I have converted centimeters into meters, plus half rho VA square must be equal to P naught, that is at point B, plus half rho VB square. So here you can cancel off P naught anyways. After cancelling P naught, rho also will get cancelled. So it even if the question doesn't mention that it is water, still the answer would be same, because the answer will not depend on the rho. Now, when you cancel rho, this, and one more equation is there, the equation of continuity, that is 6 times the area at A times velocity at A is equal to area at B, that is 3 centimeters square, times velocity at B. So you can write VB is equal to 2 VA. So here you will have what? 0.5 is equal to, when you substitute VB is equal to 2 VA, you have 2 VA square minus this one goes there, then you will get what? 3 by 2 VA square. So VA you will get as 1 by root 3 meter per second. Now when you want volume flow rate, you just have to multiply with the area. So, and even this has to be converted into centimeters. So that will be 100 by root 3 multiplied by the area at A. Area at A is what? 600, 6, that's it, 6 centimeters square. So that will give you 200 root 3 as the answer. Okay? Chalo, let us go to the next question. In an experiment, the two values of spring constants are given, K1 and K2. If the springs are connected in parallel, then the percentage error in the equivalent spring is asked. Fine. So you should be knowing the formula. First of all, two springs being parallel is like this, K1 and K2. Let us say they are connected to a block, for example. And the effective spring formula you should know when they are connected in parallel, it is K1 plus K2. So because of this addition, you are supposed to add the absolute errors here. Delta K effective is equal to delta K1 plus delta K2. And yeah, you are not supposed to add the relative errors, but absolute errors. For example, let us say if you have some A is equal to BC, that is multiplication, then you are supposed to add the relative errors. I hope you know it. And then there is one more thing. If the springs are in series, okay, this question is over actually. Okay, by here till here, if you do, you will get zero point 0.5, and then the K effective is 30 because it is 10 and 20, and therefore the relative error here or percentage error here will be 0.5 divided by 30 into 100. Do the calculations, you will get your answer. That is 1.67. Now, suppose if the question were given like this, that is, if the springs are connected in series, that is 1 by K effective will be equal to what? 1 by K1 plus 1 by K2. Here, you may have to use a different way to find the error in the K, that is K effective. So that would be minus dK effective divided by K effective square, okay, is equal to minus dk1 by k1 square minus dk2 divided by k2 square. This is how you do it. A very similar formula, a very similar method is adopted for the mirror formula also, that is 1 by v plus 1 by vu is equal to 1 by f. Here too you are supposed to use the same kind of formula. Okay. Coming to the next question, a 4 kg mass moves under the influence of a force. Time is given. You are supposed to find velocity and position as a function of position at 2 seconds. So let us see. This is a simple question. You can do it properly and get the answer. Not an issue. Very, very elementary question. That is, you need to find acceleration by dividing force with mass. You will get t cube I cap minus 3 by 4 t j cap. So this is one thing. And then you'll integrate this with respect to time. Then you'll get velocity bar, and then you'll again integrate this. Then you'll get r bar. Okay. So how do you do this? V bar dv bar by dt is equal to a bar. So dv bar is equal to a bar dt, integration both the sides from 0 to 2. This will give you the velocity at 2 seconds minus velocity at 0 seconds. But velocity at 0 seconds is 0 because he says the mass starts. All these things you are supposed to mind in the exam. If it doesn't say that it is starting at t equal to 0, you are not supposed to take velocity at t equal to 0 as 0. So, yeah, velocity at 2 seconds you can calculate from here. You will be getting your answer. And then once you get velocity as a function of time, here you will get velocity as a function of time. How do you do when you integrate it without substituting the limits? Don't substitute limits when you are trying to find it in terms of time. This you are supposed to put as t if you want velocity as a function of time. The velocity as a function of time, you will get it as t power 4 by 4 I cap minus 3 by 4 t square by 2 j cap. This is what you get. This is velocity as a function of time. Why do you need velocity as a function of time? This I will like to write as dr bar by dt, and then again integrate to get r value as a function of time, and then I will substitute 2. Okay, so this is what you are supposed to do in a normal way. So if you leave the convention way, forget about the convention way, look at the answers. The answer which has minus in between, that is supposed to be the answer. Okay, clearly. This minus is not going anywhere. This minus is not going anywhere. So minus should be there. So 2 and 4 you can boil down to 2 and 4 options. 1 and 3 you can eliminate. And then what? So here again, you're never going to get 6 in the numerator. You're going to get 8 only in the numerator. Now why I'm confident of that? Look at this, 8 by 5 I cap. So look at the I cap one. You have t cube I cap in acceleration. When you integrate it, you'll get t power 4 by 4. When you integrate it again, you'll get t power 5 by 20 and so on. But you'll never get 3 in the numerator. Do you get 3 in the numerator, which is a factor of, factor of 6? You'll never get never get 3 in the numerator. So you don't have to bother about that. So when you substitute 2 in this, that is 2 seconds in the end, you're supposed to get Only this answer, that is 8. And no other option is there where which is very appropriate according to what we have discussing here. So the answer is 2, and it all happens in just 30 to 40 seconds. Yes, it happens in 30 to 40 seconds if you think like this. Now if you keep integrating things and do this, then it might take, let us say, 2 minutes. Okay. Yes. The next question is about units and dimensions. It's not Bernoulli's equation. Of course, it is Bernoulli's equation, modified Bernoulli's equation, but the question is about units and dimensions. Now, A by BT square, as you know it, should have units of pressure. Okay. And BT must have units of height. Okay. That much we are sure. Now, what I'm trying to do here is I will divide these two. That is a by bt square by bt. You will get a by b square t cube. Okay, which should have units of pressure by height. That is nothing but rho g. Okay, rho g. So a by b square should have what units? Rho g into t cube units. These are the units you are supposed to have. Now, what are the units of this? This is m by l cube multiplied by L by T square multiplied by T cube. Okay, so it boils down to what? M L power minus 2 T. So this is what it is. The A by B square units are what? M L power minus 2 T. Now why I am doing this way is, if you go to the question now, check which of the following options will give you A by B square as T. That is the first one divided by square of the second one should give you m L power minus 2 T. Now you might be thinking this is an inappropriate method. No, this is very appropriate method, because you are supposed to check m power 1, L power minus 2 and T power 1. All three should match. Only then the answer would be correct. So look at the options. There are not many options which are very convincing. So it's an easy way to do it. Of course, the normal way to do it is always there. So I will go with this. Look at it. You can, just by looking at it, you can tell the answer. M and L you don't have an issue. Only T you need to check, because in all of them M and L have similar dimensions. M power 1 here, everywhere M power 1, M power 1, L power 0, all of them. Here M power 0, here L power 1. So you just have to take T and check T, and which one of them will give you T power 1. That's the answer. That's it. Okay. Yeah, this problem is all about your confidence in the chapter, or you may say physics. So this, you have a solenoid like this, and a charge is going like this, it seems. Now the magnetic field is present in the same direction as charge moving direction, so there is no force first of all due to magnetic field. So it just falls with A equal to G. Now he is checking your confidence. Is it the same question he has given or not? Like, can the question be so easy? That's what he wants you to feel. Okay. Now this question, look at it, looks terrifying, but it's very easy question, because look at this. A capacitor plate is given, and you have 1/3 of the length filled with dielectric constant K. But have a look at it. If you, what is the dielectric constant for free space? Free space. The dielectric constant is what? K is equal to 1. So if you put K equal to 1, what should you get? Because this point, this space is filled with free space, right? I mean, there's nothing there. Okay. And if you fill up this also with free space, what should be the answer? The answer should be C. Now, if you have K equal to 1, the answer should be C. So check which one of these options is giving you answer as C when you substitute K is equal to 1. Only one is giving. Look at that. You can check for yourself. None other options is actually giving you the C as the effective C as C when you substitute k is equal to 1. I checked it. Now, yeah, you may check, so you can't be certain, let us say, with only one substitution. You substitute k is equal to infinity. What do you mean by k is equal to infinity? K equal to infinity means this being conductor. So if that is conductor, you can change the diagram. The diagram changes to this. This alone is the capacitor. Till here you have wire. It means that because this also is conductor. This is also conducting. So that also is a wire. So only from here to here is the, this gap is the gap you have in the capacitor plates. That's how you can assume. Now if you assume like that, that is 2 by thirds length, 2 by thirds length is there as free space. Now find out with k equal to infinity. K tends to infinity you're supposed to put, not just directly substitute k equal to infinity. If you substitute k equal to infinity, what are you supposed to get? See, you know that the capacitance of a capacitor is given by what? Epsilon A by D, normal capacitance. But if only 2/3 is there, then C effective will be what? 3 by 2 times epsilon A by D. Substitute 2 by 3D instead of D. This is what you get. Now, if you substitute k is equal to infinity or k tends to infinity, which of these options is going to give you this answer? That's the answer. Okay. Now, see, why I'm teaching you this? In this problem, it is not necessary. But let us say two options are giving you C value when you substitute k is equal to 1, let us say. Two options are giving you correct answer. Then you can substitute one more option, one more value, that is k tends to infinity. Okay, so that's why I was actually telling you. Next one is about electromagnetic waves. So here you are given EY. First thing you should do is check the direction of the wave. The wave is moving in X direction. So which one of these should you take such that by doing E cross B you should get I cap. By doing E cross B you should get I cap. So BZ 1 or 2. Okay, so out of 1 or 2 options you are supposed to select. Now which one of these options is going to give you E naught by B naught C? Both. Okay, fine. And which one of these options is true then? This. Why? Because you have minus here. That means positive x direction. The propagation of the wave is in positive x direction. So you cannot have electric field, you cannot have minus, and magnetic field, you cannot have positive. Okay, so either both of them should have negative or both of them should be positive, because due to both combinedly are telling you that the wave is moving in positive x direction. Yeah, in this question, that is 36th question, the distance between slits is given, distance between the screen and the slits is given. This is given as 50 centimeters and this is given as 0.1 centimeter. And the fringe is shifted because there is a transparent sheet here. So it is shifted by how much? 0.2 centimeters. Now you should know that the fringe will shift towards the sheet. Whichever before whichever slit you put the sheet, that side the fringe will shift. So here you have the central maxima now. So the angle here is theta, let us say. The theta is given by 0.2 divided by 50, and this is part difference d sine theta, which can be equated to d into theta approximately, and this d into theta can be written as d tan theta. So therefore we can write it as 0.1 times tan theta is this, So 0.2 divided by 50, that is the part difference, which must be equal to mu minus 1 into T. Now, why is this mu minus 1 into T? That's a story you should learn from the theory of Young's double slit experiment. If you don't know, I need to explain that fully, but I'm not here to do that now. So let us look at it. Mu minus 1 into T is what? 1.5 minus 1 into T. That is 0.5 into T. So do the calculations, you will get your T. So here you see the calculations. How are the calculations? 2 divided by 25, something like that you are going to get. So the answer is 8. You don't have to worry about the order here. Okay. Yeah, then the next question is about photoelectric effect. Here electric field function is given, but kx is not given in the wave function. 60 sine some omega t plus sine some other omega t. Okay. So this omega actually represents what frequency? Angular frequency, but yeah, you can convert that into frequency. Now work function is given. The maximum kinetic energy of the ejected photoelectron is what is asked. Now, please, when I do this question, what I will do, look at the options. 5.1, 6.0, 3.8, 7.8. See, I am sure that this question is not hard, it's easy, but then you have a lot of calculations. What are the calculations you have? Hc by lambda, that is the energy of the photon, minus work function is the Ke max. This everybody knows. So doing this hc by lambda and finding the answer, that you have to do. Now, I am not going to do it exactly, but then I will definitely take the right answer. Now, how I do that? Just observe what I am trying to do. Now, work function, look at the work function, 2.8 electron volts. And then look at the answers, somewhere like this. Now, even if you add 2.8 to 7.8, hardly you are going to get what? 10 or let us say 11, right? Maximum of 11. So you are going to get hc by lambda less than 11. Okay, anything which is less than 11. So that you put it in mind, 11 electron volts. Now, what I'm going to do is hc by lambda, I'm going to calculate. Let us see. Quickly, I will write. I will not exactly do the calculation. 6.6, only number I will consider. Multiplied by C is what? 3, or C by lambda is what? C by lambda is frequency. And of course, you know that the higher frequency of these two you are supposed to take. Yeah, that is one mistake the students are bound to do. That is, they might take the lesser one, which will not give you the answer. Why the higher one? Because he is asking maximum kinetic energy. So obviously, you need maximum energy from where you will subtract the work function, and then you will get the maximum kinetic energy. So if you consider C by lambda, which is nothing but frequency, that is omega by 2 pi. Omega is 12 into 10 power 15. I don't care about 10 power 15. Divided by 2 pi, that is 6.28. This is one thing I will do. Next what? I have to calculate the value of this, and yes, I have to convert this into electron volts again. So how do I convert this into electron volts? Divided by electrons charge, 1.6 into 10 power minus 19. Again, I'm ignoring the 10 power something. Okay, so look at it carefully. hc by lambda I have done. That is h nu I have done. And then divided by electrons charge will give you what? The energy of the photon in electron volts. This is what it will give you. So just I am going to calculate this. So what I'll do is, look at this, 12 divided by 1.6. I don't care about the decimal 1.6. 16, I'll consider it as 16. So 12 by 16, that is 3 by 4, 0.75 multiplied by 6.6 divided by 6.28, slightly greater than 1. So I will take it as 1.1, let us say. So that will give you what? 7.8 maybe. Okay. Now you might be thinking, how I have arrived at 7.8 and all that. Don't worry. See, it will give you 0.78, but still I will write 7.8 because I am interested in that order. Look at the answers. I am interested in 7.8. not 0.78. After doing everything with 10 power something, you have to get 7.8. Minus 2.8 will give you 5, nearby 5. So my answer is 5.1. That's it. Yeah, the next question. If an alpha particle has so much energy and 7.7 mega electron volts energy is there, yeah, is bombarded with thin gold foil. The closest distance from the nucleus it can reach is, yeah. So how do you typically do this question? You have a gold atom, let us say, gold atom, and an alpha particle is approaching this. This has an energy of 7.7 mega electron volts. Fine, that's the kinetic energy. Assuming this gold atom is fixed because it's a part of thin gold foil, it will come very near, let us say, to some distance, and this distance, the nearest distance is, let us say, r. Then when it is nearest, then the potential energy would be what? K q1 q2 by r, which must be equated to the initial kinetic energy, that is 7.7 mega electron volts. Because initially we are going to assume that the potential energy is almost zero because it is coming from very far. Now K value, you are given K value 9 into 10 power 9 multiplied by charge of alpha particle. Yeah, some people are going to definitely take charge of the alpha particle as 4 electrons charge. No, that's wrong. Obviously, you know it. You might have gone wrong there. Just 2 electrons charge you are supposed to take. So 2e, I will write. And then the charge of the gold foil, 79e. Fine, divided by r. Yeah, some people tend to write r square. That is a problem. You should take care. Okay. So that you equate it to 7.7 mega electron volts. So 7.7 to 10 power 6 into EV. Okay, V. So EV. Now what I'll do is I'll cancel this E with this, and let the E be there, the other E be there. So this is what this calculation I'm supposed to do. So again R is equal to, again I'm not going to, yeah, I have to mind about the order also here. Why I need order? Because you have 2.25 and 2.25 here, and the order is different. That's a problem. And again 3.85, 3.85, and the order is different. That's a problem. So I need to do it carefully to the last decimal. I need to do the calculation, as well as I'm worried about the order of the answer. So let me do it then. 9 into 2 into 79, 2 into 79 E divided by 7.7. And the remaining things what are there? 10 power 9 is there, divided by 10 power 6 is there. Yeah, it's done, right? Now 7.7 is there, so this, take this point away, and this I will write as 5. And then 77 and 79 I will cancel off and write it as 1. And then what? 18 is there, but then you have 18 16s. 18 into 1.6 into 10 power minus 19 into this is 10 power 4. So 10 power minus 15 you will get here. Fine. And 18 into 1.6. Tell me how much will be 18 into 1.6. Now don't just multiply like this, 18 and then 16 and do the multiplication. Don't do that, come on. Okay, you can write this 1.6 as 1.5. So if you write it as 1.5, it is like 1.5 times of 18. 1.5 times of 18 is 2.7. So 2.7 is nearby 2.95. Because you have decreased 1.6, yeah, you expect obviously the answer should be more than what you are getting it. So 2.95 is fine. And the order is what? 10 power minus 15. Yeah, somewhere, yeah, this point we have missed. So 10 power minus 14. That's it. Yeah, there is a flaw in this question actually. Now, what is the problem here? See, let us say, as you see from the alpha particle, let us say this is a gold atom. Now, the alpha particle need not approach the gold atom right head on. Let us say you have four gold atoms like this, okay? And the alpha particle may approach like this, okay? That is towards the midpoint of these four gold atoms. Now, that might lead to the nearest possible distance. That's a thinking point, and that is not taken care. This question is very easy question. In the class, we have done much better problems than this. In the class, we have done a square plate hinged at this point and then hanging with a thread like this. And when this thread is cut, okay, what would be the acceleration of the center of mass? What are the hinge reactions? And what if you stand at the center of mass and do the problem? What if you stand at this corner and do the problem? All those things we have done in the class, and this is very easy problem. Okay, now one of my students has ticked this one as the answer because just after cutting he thought that the tension won't change much just after cutting, and so each of the tensions will be equal to mg by 2, so it should be mg by 2. That's what he thought and ticked the answer, so that's obviously wrong. And what you do here is you'll write the torques. Mg is there. About this point is stationary, you don't have to write any pseudo torque. So mg into L by 2 is what you'll do, is equal to I alpha. I about that point is ml square by 3 into alpha. And the dynamics equation, mg minus t is equal to ma. A is the acceleration of center of mass, that's what you're supposed to do. Acceleration of center of mass is what? L by 2 alpha, because tangential acceleration, assuming this is the point about which it is rotating in pure rotation, A is equal to L by 2 alpha. That is what we will take. So L by 2 alpha. So solving these things, you should be getting your answer. Here quickly we will do it. So alpha is given by 3g by 2L, that you will substitute here, then we'll get mg minus t is equal to 3mg by 4 and t is equal to mg by 4. Now, what can be the, can anything be there apart from this which you can do such that it can be done without actually doing the problem? Think. How will you take the answer mg by 4 without actually doing it?